Okay, today we are talking about our other trig functions. There are 4 of them. We have the tangent, right? That's another one of our trig functions. We have the cotangent, we have the secant, and we have the cosecant. Those are your other 4 trig functions that we're going to talk about in graph and stuff. Okay? Let me bring your attention to the period. The period for tan and cotan is pi. These are the only one of our 6 trig functions that have a period that's not 2 pi. Period is pi. Okay, the range is all real values, but the domain is not. There are places on our graphs that the x value cannot be, so we have a limited domain, but we have an unlimited range. Okay, notice there are asymptotes. So how do we know when there's an asymptote? Well, what happens if our denominator is 0? Right, if your denominator is 0, that means your function is undefined at that x value. And everywhere we have an undefined function, we have a vertical asymptote. So all of our graphs of these other trig functions have undefined values. Okay, everywhere the cosine is 0, the tangent function will have an undefined value because something divided by 0 is undefined. So everywhere cosine is 0, tan is going to have a vertical asymptote. Okay, likewise for cotan. Everywhere sine is 0. Okay, cotan is the sine, cosine over the sine ratio. So everywhere that sine is 0, we're going to have a vertical asymptote for cotangent. Okay, that's part of our graphing. We're going to identify where the asymptotes are, and then we're going to do all of our other points based upon those asymptotes. Okay, even for secant, right, wherever cosine is 0, secant will have an asymptote. So notice this dashed line here. This is a graph of cosine. Okay, so wherever cosine has a max, secant has an upward facing parabola. It's not a parabola, but we'll just use those words because we're used to graphing. And everywhere cosine has a minimum, secant has a downward facing parabola. Okay, so every max, there's an upward facing parabola. Every min, there's a downward facing one. And these don't cross your vertical asymptotes. Okay, likewise for secant or cosecant, right, wherever sine is 0, so sine is 0 at the origin, so we have an asymptote through the origin. We have an asymptote at pi. Everywhere sine has a max, cosecant has an upward parabola. Everywhere sine has a min, cosecant has a downward parabola. So if you are very familiar with your sine and cosine graphs, then these other trig functions are pretty easy. So let's talk about finding periods. Notice for tan and cotan, right, it's absolute value of b. There can be negatives because we can have positives and negatives, but the period is pi over b. We're never going to have a negative period. Okay? For tan and cotan, that period is pi over b, 1 pi over b. But for our buddies secant and cosecant, just like sine and cosine, we have 2 pi over b. Okay, and our transformations are the exact same, right? So this is your transformation equation just like we had on the board. The a has a different name. Okay, your a, which was called your amplitude for sine and cosine, is called your dilation. Okay, so that's the only thing that changes is the word for your amplitude is now called dilation. You still get your period from your b value. Your C is still your phase shift and it's always opposite. D is your vertical shift. So all of those things come in the same place as the sine and cosine. Only now we have the words tan, cotan, secant, or cosecant. Okay? That's really all that there is different between them. So in other words, no difference, except for the vocabulary, which is a dilation. Okay? No amplitude, since there's no maximum or minimums, so we call them dilations. Okay, so here's 6 examples of calculating period. So in each of these, we want to identify the b value and then write down the correct fraction for each. Whenever we have a tan or cotan, it's 1 pi over your b value. And whenever we have secant or cosecant, it's 2 pi over your b value. And of course, if we divide by a fraction, we multiply by the reciprocal in order to get our final answer. Okay, let's talk about how we graph things then. So this is a poster that I keep up in my room to help my students remember how to graph tans and cotans. Okay, so we're not going to do any calculations except for finding your period. Okay, so we do the period first, and then the vertical shift, and then if we're graphing tan, we put the asymptotes in the middle of the period that you marked, and if we're graphing cotan, you put the asymptotes on the periods. So tan goes in between, and cotan goes on. And then you put the zeros in the middle of your asymptotes on your midline. So it's not always on the x-axis if we have it been shifted. And then we put in our dilation in the middle of those things. So we'll talk about how we do the dilation also with a couple of these graphs. Okay, so those are the steps. So we're going to skip the normal tan and work on tan of 2x minus 2. So our equation has a b value of 2. So we have a period of pi over 2. Okay, so when we have this blank grid, we can put them wherever we want. So come out an arbitrary amount, put a tick mark, and label that pi over 2. Okay, go out in equal amounts, and that's 2 pi over 2, which is just 1 pi. And then we go a negative amount the same, and that's negative pi over 2, and that should be all that we need for our graph. Okay, so tan says, oh, next we do the midline shift. So this is your midline shift. We're moving this graph down 2 units. So we put 2 units, we put 3, and at the negative 2, where y equals negative 2, we put in our horizontal midline. Right? On your midline is where your zeros go, not on your x-axis. That's our new middle of our graph. Our next step is to put in our asymptotes. So for tangent, that goes in the middle of your period. So between pi and 2 pi, we put in some vertical lines, vertically dashed lines, representing the asymptote. Between 0 and pi over 2, we put in a vertically dashed line representing the asymptote. Between 0 and negative pi over 2, we put in a vertically dashed line representing the asymptote. Now we put our zeros. Our zeros go in the middle of your asymptotes. So at pi over 2, on that midline, at pi, on the midline, at 0, on the midline, and at negative pi over 2. Okay, those are where all the zeros go. They go in the middle, the exact middle of your asymptotes. And finally, we do our dilation. So we have a dilation of 1, because there's no number in front of tan. So this is our standard way of doing it. Okay, we go halfway between the 0 and the asymptote, and we go up that dilation factor. So if it's 1, we go up 1 unit. To the left, between the 0 and the left asymptote, we go down 1 unit. And we continue doing this pattern until we run out of graph. Right, we go halfway and up. Left, we go halfway and down. Right, we go halfway and up. Left, we go halfway and down. This is how we do it for tan. I guess I don't have another 0 on that side. I do have one here. So we go right halfway and up 1. Okay, that's our dilation. If that were a 3, if this were a 3 tan, we would go up 3 units from your midline, and we would go down 3 units, making your graph much skinnier. Right? It has been dilated or been stretched out. So now we have to connect these with a nice, as smooth as we can curve that goes at the lower left, goes through your points, and ends up out the upper right. So don't cross your asymptotes. Make sure it goes through your 3 points. Okay, tangent is an increasing function, so the y values on the left side of your asymptote are negative, and the y values on the right side are positive. So our graph grows from left to right as we go on our axis. Okay, let's look at our next one, which is a cotan graph. Okay, so cotans are done differently. They have a different set of, well, the same rules, but in a slightly different, same order, just slightly different. Okay, period. We always start with a period. We have a b value of 1, so our period is pi. So on our graph, we come over an arbitrary amount, and we put pi, and then 2 pi, and if we can fit it, we can put 3 pi, and negative pi on the left. Okay, our next one is to put in our asymptotes. Now, we're not going to do very big ones because hopefully you notice this has a right pi over 2 phase shift. So all of our points, our zeros and your asymptotes are going to get shifted. So in order to keep our graph kind of neat, we're not going to put huge asymptotes on there, the full entire graph like we did last time. So for cotan, we would usually put asymptotes at your period. So at negative pi, at 0, at pi, at 2 pi. This is where they would normally go if we didn't have a phase shift. But because we do have a phase shift, we have to move each of these asymptotes to the right, pi over 2. Which means they're going to end up in the middle, right? Because if I've marked my blue lines at pi, half of pi is, well, pi over 2, right in the middle. So we're going to put your vertical lines, your vertical asymptotes, at the pi over 2's. Because it has been shifted pi over 2 units from your standard position of your vertical asymptotes for cotan. Now let's put it on our zeros. The zeros always go in the middle of your asymptotes. So at the origin, and at pi, and at 2 pi, and at 3 pi. These are going to be the zeros where your graph crosses the midline, which in this case happens to be the x-axis because there's no vertical shifting. Now for tan, we went right and up, and left and down. For cotan, we do the opposite. Okay, cotan, we go left, up, left halfway, and then up 2 because we have a dilation factor of 2. So standard practice is to go over halfway up 1, but because we have a dilation of 2, we go up 2. For cotan, we go left and up. And then if we go right halfway, we have to go down 2. Okay. Left and up for cotan, right and down for cotan. Okay, not the same thing as tangent. It's not the same function, so we don't do it the same. You go left and up, right and down. So these are our points that are going to help us to make our graph nice and accurate. So now let's connect these dots. From left to right, we go down for cotan as we go through these points. Start on the asymptote high on the left, and we go to the asymptote negative infinity on the right. Okay, cotan is the opposite of tan here. So the graphs look different, of course. Okay, so if your graph grows from left to right and it's positive, right, this is your typical tangent graph growth. And if it is being negative, right, decreasing from left to right, this is your typical cotangent graph growth. Okay, because eventually we're going to be writing equations, and we can write a tangent graph if it grows from left to right, and we'll write a cotangent graph if it decreases from left to right. Okay, so those are little things about tan and cotan, and a couple things about secant and cosecant. We'll graph some more of those next time. All right, have a swell day.